So we have discussed the gradient and the divergence. Now let us discuss the curl. The curl. Let me mute some of you. Okay, the curl. If v x y z, v is a function of x y z, is a differentiable if v vector is a differentiable vector field, then the curl or rotation of v written as del cross v or curl v or rotation of v. Rotation of v is defined by curl of v is equal to del by del x, dou by dou x I hat plus dou by dou y j hat plus dou by dou z k hat. This is for del. Del operator is dou by dou x plus dou by dou y plus dou by dou z multiplied by I hat, j hat, k hat. And this cross product we have cross here. Then v is v1x, v1 I hat plus v2 j hat plus v3 k hat. So this is like the cross product of two vectors, and we have the determinant of this. I hat dou by dou x and v1. We have j hat dou by dou y and v2. Then k hat dou by dou z v3. So this is the curl of the vector v. Okay, and this should be equal to this should be equal to del v3 by del y minus del v2 by del z I hat plus dou v1 by dou z minus dou v3 by dou x j hat plus dou v2 by dou x minus dou v1 by dou y k hat. So when we expand this determinant, we get this expression. Okay, and you must remember that in the expansion of this determinants, the operators dou by dou x, dou by dou y, dou by dou z, they must precede v1, v2, v3. So this is the definition of curl. So what have we discussed so far? We have discussed the gradient, the divergence, and the curl in Cartesian coordinate systems. Then what is our next aim? And what are we going to do next? Now we are going to express the gradient, divergence, and curl in orthogonal curvilinear coordinates. I repeat, we are going to express the gradient, the divergence, and the curl in orthogonal curvilinear coordinates. Okay, So I think that we'll do in our next class, how to express gradient, divergence, and curl in orthogonal curvilinear coordinates. We'll discuss that in the next class. So I think that's all for today. Let me stop the recording here.